also like to welcome B. Krishna Prasad sir and Amit Mahajin sir, who are the other scientists present here today. I would also like to welcome Mrs. Mamta, who is present here today for today's session. I request everybody to rise for the Shanti Mantra. Om Shri Gurubhyo Namaha Harihi Om Bhadram Karnebhi Shrunayama Devaha Bhadram Pashyemakshabhiryajatraha Sthirairangai Stushtovagam Sastanobhihi Vyashema Devahitayadayoho Swasti na Indro Vruddhashavaha Swasti na Pusha Vishwavedaha Swasti nastaksho Arishtanemihi Swasti no Brihaspati Dadhato Om Shanti 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 Harihi Om. I will give you a brief insight about the Focus Assist sessions in Vidyashala. Focus Assist is a motivation and career guidance program for the students incorporating the best practice.
To present that in the presentation it was not there. And as Swamiji has told, the space, actually we are told, you got an astronomy lab and observing the what they call sky and stars is fascinating and is very good. But at the same time, what the satellites, I worked for the past 36 years in the satellite making. Say, you know what is the satellites? Any one. Satellites, you know? Okay, good. Okay, right enough. So then, shall I start, sir? Okay, with this introduction, I'll go that where the satellite and satellite applications. See, we are in the space. When you go to the outer space, and what is the use? What is the space of satellite? What is the usefulness of these all space instruments for us? That's where with that I'll do. Next. So, Indian space program, it is useful for us. Whether that we'll see. Next slide. Ready there? You got a laser point. Okay. Yeah, I understand. PPT. RK Ashram PPT. What? Okay, students, this is the way actually I am looking for the over Indian satellite program. Just now I told, it's a satellite. As I asked, what is a satellite? Somebody, one of the student, actually has told that what is the moon. Moon is a natural satellite. Just go for next. Okay, I'll go. Okay. This you have seen our sun, earth, moon. So the earth is rotating around the sun with the 365 days, whereas moon is around the earth. That is a satellite. So how to use our satellite is a natural satellite. Moon is a natural satellite. Whereas we make artificial satellite to use the mankind. Understood? So we will see the satellite. We are in the Bangalore ISRO Satellite Center. We make satellites in India. Bangalore it is made. Now slowly it is coming to the private industry. Earlier ISRO, Indian Space Research Organization, makes satellites, rockets, and it launches and it gives the application to the people. Common man, how it is. That's what I am going to take you around. Next. So what that our father of the Indian space vertical is a visionary. It is called Vikram Sarabhai. When it was started in 1957, what we have felt is it is not that time the Russia and the American was going for a space competition. We thought not competition. It is a mankind. What I told. So but. See here, the mankind, it is a society and problems of the world. The technology, advanced technology is real world and problems what we have to do. The satellites what we have to use for the sake of how to solve the man and the society problems. So that's why we have come on the way for the past 60 years. So the many things we have come forward and you are able to see that the satellites and its applications, its technologies for how it has reached a common man. So this is what your Ramakrishna Ashramam when you see. So from your RK Ashram in from satellite 500 kilometers. You have seen all people. You have seen the Google Earth map. Yes, like that way you see 500 kilometers. But where we use this is our ashram we see. So Indian satellite program, this is my topic today. What is the Indian satellite program? What we do in the Indian satellite? So we use the Indian satellites. See, this is the communication satellites, Earth observation satellites, and the scientific missions, and the navigation missions, and the experiment satellites, and the student satellite, small satellites, and the student satellites. There are the different programs are there. Today we will cover the communication satellite and Earth observation satellite, how it is useful, and future where we are going to do that. So this is the ISRO. You know, everybody knows ISRO? Yeah. What it does? It makes rockets as well as satellites. Right. That's all. So for our organization, Indian Space Research Organization, ISRO, made a totally 116 spacecrafts. Spacecraft means satellites. It is a artificial satellite. Moon is a natural satellite. Whereas this what we are doing is a artificial satellite. How it is useful. Next, launch vehicles. How many launch? Because this satellites we have to take into the orbit, we have to take rockets. Correct? That rockets we have made, that are called launch vehicles. We have done 86 launch vehicles. And it is a student satellite. Different students from the universities Student satellites they have done. That's we also launched from our ISRO has launched. And the 2 re-entry missions. As on now, India don't have technology to go there and come back. We need to do experiments. That's what we have to take the satellite and we leaving the orbit. Then it is come back. That re-entry, it is once again we have to bring it back. So that's re-entry experiments we have done too. And these foreign satellites, even in our rockets, which we are capable of launching, the satellites are not only our one, other people also came and asked ISRO, please launch our satellites, that foreign, the 381 satellites, small, big, both the things we have able to launch 381 satellites we have launched. So one of that is 104 satellite when we have done, first time we have done other before SpaceX. So that's what I'm telling, that is a great record, it was there. So we only, 104 satellites, we are small, it was not a very big thing. It's a small satellites we have launched into the orbit. That's the world record we have done. We are proud of that. So when it comes to the satellites, how the satellites will go? The satellites will go around in a different orbits. It goes to the Geo means geostationary orbit. With respect to when 36,000 kilometers it is there, it will be around, it is equal to the same place. Or your telecommunication, your broadcasting, TV broadcasting will come through this. Whereas the medium Earth observation satellite on 5,000 to 20,000 kilometers we all launch. The LEO, it means a low Earth orbit satellite for observing the the Earth and land mining, all these things, application, different applications on the Earth, what we will take images and we will use for the different department, agriculture department, mineralogy, all these things we will do that. So this is the geostationary. See that you are seeing that the satellite you keep here around 36,000 kilometers. This always sees one place. In this picture, you are able to see only one place. So you launch that is covering the only that. When you keep your 36,000 kilometers away, it will go on rotating. It is equivalent to stationary. That's why it's called geostationary. Geo means Earth. Stationary means with Earth is rotating around. It's correct. Am I right? Earth is rotating around. It's how many revolutions per day? One answer. That is 24 hours once it rotates. When it rotates, if you keep a satellite fixed, it cannot be moving away. Then you have to keep a distance somewhere in the geostationary. It moves along with Earth. So that's what it shows. Anything you transmit, its entire country will be transmitted. For the sake, it is a fixed. That's why with the geo means Earth, stationary. With respect to when I see from this place, it is a stationary. Is it also moving 24 hours in a one circle? So that is around 36,000 kilometers from the Earth. If you put the satellite, it will be rotating around 24 hours per day. Earth also rotates 24 hours. It means it is equivalent to stationary with respect to Earth. Got it? So that's where you see this place, what you are able to see that. So next is the polar satellite on sun synchronous. With respect to sundial, when the satellite moves from the north pole to south pole when you get, because sun moves, when the sun moves like this from here east to west, when it is doing, when we take the pictures of the Earth, we have to take them. When sun moves 15 degrees per hour, 1 hour it will sun moves, because then equal light conditions you have to check your imagery you have to take. We are taking a photograph, Earth photograph you are taking. When Earth photograph you are taking, we should know every day you have to take same lighting conditions. That conditions we should have. That then we have to have a north pole to south pole. That is the sun. When sun it comes with respect to sun. Whenever it crosses the equator, every day 10:30. I'll keep one particular orbit. 10:30 daily 10:30 will take. Your ashram will take every day 10:30. What happens? Whether it is any changes happened, over a year, over 10 years, like that we can see. To day. Generally day to day will not happen. We'll see that. That I'll go to further slides. So these are the two synchronous orbits we done. So both the things, satellites are in both ways. If you make it like this, few satellites will be rotating the polar orbit, some few satellites will be rotating around the they were geostationary orbit. These are the called communication satellites. These are the communication satellite. This is the sun polar orbits or sun synchronous satellites. That are the imaging satellites. So then when you take the entire Earth photographs, what we have to see, you just touch that. You click. Now it is all, we are taking a photograph, when it moves, we cannot take the everyday movement. See, number of satellites, you touch. No, not that. See, now one satellite is moving, so it takes a photograph. When Earth rotates, you take that. Once again, you want to see in our satellites, based on the camera, it takes on our entire country of our India to cover it, 22 days it takes. But it takes number of satellites. If you go, it will be, see now you see, I put more satellites. The more satellite will cover, so that's the cut of every part of the country. I need not wait. So there is a Planet India. We are taking a number of satellites we launch, and we take the entire Earth in a single day. That's such, so many satellites we are launched, number of satellites such that entire area we can take. In India, we will look, our satellites, maybe 5 or 6, we will cover entire country. Whereas Earth, you want to see that Google Earth map, or these people are covering entire Earth with a lot of satellite constellation. Number of satellites you have put into orbit, they will take the photograph entire Earth every day. This is the thing, you got to that. Got it? Next. So then whenever the satellite goes to that, into the orbit, we should have solar panels deployed. Correct now? This solar panel deploy, it gives, and the take pictures, its energy is required. So solar panel, how it is deployed, just I'm showing for your interest that it goes there, because we cannot launch full satellite into the rocket with like this. Then we have to go like this and stretch. That panel will be just. This is the way how it is stretched the entire satellites. So the solar panels are deployed and gives energy to the satellite to do that. Coming to the communication satellite. Now, these are the different communication satellites what we have. So I told how it is applied. The satellites are launched into the orbit. How it is useful? We should have a communication. So there's a different communication satellite. If you put in a geostationary orbit, it will be useful for our telecommunication. There many applications are there. I'll show that. So that is a telecommunications. Television broadcasting, what you are seeing, the TV channels, all channels ready, and weather forecasting, disaster warning, and search and rescue operations. These are the different applications we have. 200 transponders, the different bands, different frequencies we have, that what to do. So now one by one applications we will see. See, this is how the geostationary satellite, how we do that. Have you seen all this picture anywhere? You might have seen? Yes or no? Yes, okay. That's a satellite you transmit from the ground, and then the entire country it will be covered by the downlink. Actually, it is from Delhi program or any other Calcutta some programs are there. We will transmit, entire country will do that. Streaming it will be there. So this is a different application. The satellite communication satellite has got you got internet, broadband, emergency disaster, home communication, that and broadband that individuals also we can do, the business broadband, and this is the telemedicine, tele-education, and the services, different services will be there. Like this all applications will be there. These are useful for us. Why satellites are launched? These artificial satellites, we got these all applications that you have seen. Earlier when we joined, we were not having this, when we are not seeing the satellites, this many channels were not there, that point-to-point satellites we used to there. That 72 kilometers every time repeater, and we used to keep a big, long antenna to see one transmit, only one Bangalore station, Hyderabad station. Now, once the satellite has come, now entire satellite is Assami program also I can watch, or the Delhi channel also I can watch, Kashmiri channel also I can watch. It has happened because from Kashmir, they will launch, the program is uploaded to the satellite. From satellite, entire country it will be seen. Earlier it would have not, we would have not seen like this, correct? Have you seen that? The Mahabharata, Ramayana? Yes. Seen? That's what, in all languages. At a time you can see from here, I can see Telugu channel, I can see in Kannada, I can see in Assami, I can see in Hindi. Correct. Have you observed this? This is the satellites when it is because of the different channels and we are able to see. Earlier it was not there. Only Bangalore station, only we used to see, only Kannada channel. But other language people has to wait for or something, recorded programs you have to see. Now we can sit here and we can see all the languages at our place. This has come with the possibility with the satellites only. This satellite communication, it has come. That is the application of the satellite. So this is another satellite obligation. Nowadays, earlier, the railway crossing, how it is happening. Have you booked the tickets? I don't know, you are still children. Some people may where is my train? Have you seen anybody? Yeah. So how it is possible? See, whenever the train it transferred wherever it goes, application it goes to the satellite, it is given to your networks. Okay? Similarly, one application, recently we have started, what is this is, any train coming level crossing, somebody is crossing any accident and people used to do. Have you seen in the villages, there is a level crossing and trains. So then now what we have done is, when train is approaches, we have given the device to the driver also, that when level crossing is approaching. And at the same time, this level, based on the traveling, that once it is gone to satellite and one device we have kept on the level crossing, big siren will be there, such that people will not cross the road. So that will be warning them such that nobody will be crossing the train, because train is coming, be away. Even the information is there for the driver as well as this siren, big siren is for the people who are crossing the level crossing. This is another application of the satellites or communication satellites. Similarly, so the village, entire village, we can have all the satellites. In the village, wherever we are there, so we are teaching the village revenue resources, all these things. When the telecommunications, we can teach the teacher. Now you have come. This COVID, everybody might have seen. Have you seen this, all the communication through that? Earlier, it was not that popular. Now it is because it has happened because of the communication satellites. These satellites we are making. Similarly, telemedicine. See, doctor will be there. Have you heard of the cardiac specialist Devi Shetty, sir? Not okay. Not anyone expert is there. Devi Shetty, that's what. Any doctor is expert in Bangalore, it is there. So when you want to see a Kolkata patient, you want to see, he will be sitting there and he will be watching there his video from the send. Then he will send the doctor, the patient, and the local doctor will be sending the data, video data to the satellite. Satellite, the doctor will see, and doctor in turn will observe and tell. This is called telemedicine. From your your doctor, if doctor is not there also, we can see from the through telemedicine, it will come there. That's what I am saying. This Assam, anybody sitting there, here, whatever we are there, at Bangalore, we can, this expert doctor will treat the doctor. You take like this, this is the thing, this is the thing. He has to tell them what is happening to that. So this weather forecast, the cloud pictures, have you seen this? Yes. So this is where the cloud pictures, we are taken from 36,000, every 15 minutes, our satellites will take the picture. This will go Indian Meteorological Department, we will give the picture. And based on this, now this is going to be a cloud picture from the satellite. Then here is going to be rain. Here there is no rain. Then further I will show that, so how it moves. This was moving. See the cyclone, this is the ordinary cloud picture. This is the general normal, where the clouds are there, but is there or not, how the clouds are over India. Every 15 minutes, whether it's movement. Actually, this picture, it was there. See, here it was also moving. This moving. This actually, that it is not moving. See, this also, it has moved. It has from moved to here. Okay, that is not displaying here. But similarly, I want to show that cyclone. Then cyclone, how it is moving, you have seen. See, now you see that slowly it is cyclone that is moving from there. So after this cyclone monitoring, See, earlier, maybe 10 to 15 years back, many people used to die. This, when you see this, because of the satellite data, this, how it is moving from the Bay of Bengal or Arabian Sea, Atlantic Sea, that early warning is given to the people, local collector from the disaster management at Delhi or headquarters. It is our Delhi is our capital city, and the local collector, local revenue officers, they are evacuating. To some 2-3 days early, we are evacuating. Almost, I'll call, no deaths happen after this disaster management systems. Okay, understood? So if this is not there, this technology, this communication satellite, we would not happen this. Many lives used to go. Now it has not gone. Thank you. So disaster management, that cyclone warning, all these things will be. So it is not only cyclone. See, whenever it comes, it is the national department at the drought situation, any fire is there, any such things are there, we can give information to at the Delhi and the concerned departments, all these things. This is called a disaster management. The disasters are in different ways. Fire, floods, drought, vertical cyclone, all these things are there. Okay? This also. So with this, all communication satellites, have you seen that the users of the communication satellite? Clear? Okay, right. Now I'll ask question and answer session, please we'll ask afterwards. I'll be there. Okay? Now we'll go to the Earth observation satellites. Are you able to hear me? Can you hear? Okay. Last person. So now we have seen the communication utilization. Then we have we can see Earth observation satellites which is taking the picture from, earlier we used to call as a remote sensing satellites. Little soundless, okay? Earth observation satellite, we have initially we have launched, India has launched Bhaskara 1978, 79 first. That's the first Aryabhatta. What is the first satellite? Aryabhatta. After that we have launched so this is the 70s, the remote, that was this is the Aryabhatta, then Bhaskara we have launched. This is the different satellites, we have different image satellites, India as ISRO has launched. Okay, this is the Indian imaging satellite. Earlier we used to call IRS, Indian remote sensing satellites we used to call. Now it is the Indian Earth observation, we are calling as a Earth observation satellites we are calling. Okay. So what is the applications of this? This what we see is, we are seeing agriculture, water resources, urban planning, rural development, mineral prospectus, and environment, forestry, ocean resources, disaster management. All these things, departments, we use the satellite data and we will give the purpose of that. Huh? Understood? Okay. Oh sir, streaming any problem is there? Okay. I'll come. Okay. Huh? Okay, right, next. This is the agriculture. I want to show Ministry of Agriculture will having. So this one we got one application. Everybody can go to the Bhuvan satellite, a national remote sensing satellite. Is all this remote sensing or Earth observation satellite will take a lot of pictures from 500 kilometers, 600 or 1000 kilometers. Within that, we take the pictures and it is given to that. So this all data is kept there into the NRSC. That we got a Bhuvan, one site is there. We can select what are the applications of this. That such things are, you see that, any particularly, this is the Ministry of Agriculture sits at Delhi and gives all the states and this, what are the crop management, how to do, what not to do, that will be giving instruction to the local authorities, collector, revenue departments, and the concerned workers in the villages. Sir, anything you want to? No. That's so this is our Indian satellite data system. We got the Bhuvan, like Google Earth, what you see. Our Indian method, what we have seen in the Bhuvan. This is the Bhuvan NRSC. Is that website? Anybody, you all can go. So I want to show entire India covered like this picture, and I'll show one particular application. Application means where we will see. What is that? So you can tick here the area of interest. Area of interest. We have selected a Nujivido, like that. Next, what is the crop? Here it's here a mango crop, banana, citrus, like that. All these, whichever you can select. See, I have selected a area of interest, Nujivid area. What is the crop? Mango crop. This is the mango crop. Understood? This is the where we can sit at the Delhi, whether mango crop is going well or not. Our area is less or there. Whether dried up, now completed or not, like that. These are the application what we have used. See, now it's the same thing. I've shown the different camera. Now here. So this is the area I've taken. This is the mango crop, it is there. After mango crop is completed, the satellite picture also we take, and we take one, some of few people will go, really it is going or not, that also data will be there. Understand? These all areas, you got a lot of opportunities. The space technology, it has come to the ground. That is our purpose of any education. It has to be useful for the common man. Science and technology. Understood? So this is the mining. See, this in Western Australia, how the mining is happening. This is every they will take a first year, second year, third year, how the mining is happening. That's what we will do that. So similar urban planning. Urban planning means city planning. How the city is there. Here one empty place is there. What is the building is there. What are the car parked. What is the area is there. Whether any, we have to expand the road. What to do, what not to do that. Similarly, this is the one river. This is the Vijayawada, Andhra Pradesh. We have taken a Krishna river. The Krishna river and how urban place. Now we have to see 2014-22. I have to take a photograph and see how the places are there. So this the river, and this is the barrage where the water is stored and it is left the water for the sea. It is coming. Water is come from here. It left. So the canal is there. You see that you have taken a canal. These are the, from the barrage, we have given two canals for the irrigation purpose. So this, what are the urban is, the river, how the river, is it growing more or less? That all we will see. We can observe day to day or month to month and year to year, like that also we have got. I will show that future one more pictures like that. So this is the floods. One of the airport was there. So on 25th, please read that way. 25th October, 24th October. 29th October 2020, there is a airport was there. This is in Pakistan. Then it has come in September 21, the floods have come. When floods have come, the entire this was there. Then after 1 month, slowly the water is getting receded. So it is in. This is the all pictures we can see. It is the same. Understood? This is also remote imaging. The from satellite, from the distance. Daily we need not go take a photograph. Now it has come drones in the technology. Earlier it is there. And it is the drones also we cannot fly and every time and there is issues are there. But satellite we are taking images and we are able to store and tell that what is happening there. So solar panel, see solar plant in China we are doing. But how it is monitored? See initially it was there. On which day that is that? September 17, September 20. After 6 months, see this is the some more, see here, some more this, you see here there is no plant, then here the solar panels were included. Then further, it is, you said, after one more year, roughly after 1 year, this entire solar panel plant was deployment is there. That got it? How development is happened, it will be seen by the higher authorities and local, because every day they do. This is the applications of the satellite and its imageries. Understood? So this is the orange plantation. When it is an orange plantation, this is in Brazil. What is the orange plantation? It was there. It was before plantation, this picture was there. And then when the plantation is there, green. Are you able to see? These are there is a difference between this picture to this picture. This was before plantation of the oranges, whereas this plantation after the oranges. Correct? Have you seen? That's. So this is the high resolution images. This is the airport. Okay, this is the where it is almost 0.5 meters. This is the runway 1, runway 2, and all the planes are there, how it is kept there actually. So similarly, this is the high resolution images for city planning. For the city, how the city planning, this which area is common, how many roads are there, what is happening, what are the flyovers, all this. This city planning also it is done. Our SRKVS Krishna, actually in Bangalore, that's what they want to give a BDA. Okay, you are all children, but in Bangalore Development Authority, they want to plan for us many houses. How to do that? One of the chief minister was there. Then he came to the ISRO and gave me the satellite picture. So initially our scientist was not interested to talk to the politicians. Then slowly, immediately he came with one of the top scientists. He walked in the early morning. He joined with him and told, sir, he convinced him. Then he has taken that. Then one Vishwesvaraya layout. You know, Sir Vishwesvaraya, one of the great engineers of our land, he is from Karnataka. He is almost well renowned. His name, one layout is made because of the satellite picture like this only. We saw that in the Bangalore, where is the place area near to that, to the which is where residential locality we can make. Such thing is happened because of such. See, now you see, this place is vacant. This place we can build anything, either a tower or a school or a college or something. This is all the roads or sites, something. If you want to plan, this is the plan, this is the department. Such things was made. So for you, that 15,000 sites are given to all the residents of Bangalore in the benefit of the people that. So such is called Vishwesvaraya layout. It has come from because our satellite imageries. So this is the Taj Mahal Agra, 0.5, okay, Tul city. This is the Agra city, this is our Ajmal, this is the Yamuna river. So these are taken from around 1,000 kilometers or 500 kilometers. Some satellites will take that, some 500 kilometers will take a non-color picture and 1,000 kilometers will take color picture. Both will image and will combine. The airport, can try click, I think some issue is there, okay. Some issue was there actually. Yeah, you see. Over the July 19 to September, how the vegetation is happening. See, this is the plantation is there, slowly it is drying up. In July it was there, and slowly when it comes, this is dried up. Understood? Vegetation is there. Go back and click. Okay, no. This 1 minute. Here, no. Vegetation. Vegetation, okay, you click. See, now it is a plantation is there, full. Then it is slowly over the July, August, by September, it is fully, crop has come, where it has dried up. Understood? So that is where this application of the satellite imageries. Similarly, please click airport development. How airport was there in Germany? Not current. See, that's what you see. So from over 2009 to that, it is how it has developed. This all areas, how it is developed. Over a year, roughly it is some 6 to 7 years, so it is there. So actually, that's earlier it was not dried, so slowly it was seen now. That was seen, okay? That it was not there, slowly it has developed and it has come. So, okay, now with these applications, I'll come back to you. So now you have seen this, all the satellites and satellite images. Are you cleared? Now any doubts? One by one. Okay, I'll come back and I'll go to this. 1 or 2 doubts, please tell. What is the time? Okay. No, that's what they just said. Yeah.
Which is the most successful satellite of ISRO and what is the next vision of ISRO?
Okay, I'll come back. Okay, I'll tell. Most successful satellite was, okay, it is IRSP6 Resource-Sat-1. See, we have launched our satellite for the only Indian imagery only. It is launched in 2003, October 17th, we have launched a satellite. So when the satellite rotates around North Pole 30, it covers only 2 strips. I have shown you strips, okay? Only that much only it will see, take. Then next day, small rotation will be there. Then we'll go on taking. It takes to 16 to 17 days. It was resource. Then we had entire India resources we want to take. But slowly, when we saw that so much imageries are so much useful, then each satellite will go 14 orbits. Every day in a 24 hours, 14 orbits. But it goes a different time. After some time, it goes to the next Pakistan. Next, it goes to the Arabian countries. Then it goes to the European countries. Then it goes to USA. This satellite used for all the 14 orbits data was collected. So the first time remote sensing satellite we are done. For these claps are required. So India's most successful remote sensing satellite is IRSP-6 ResourceSat-1. Okay? Next, that was we never expected. We thought only for us 2 orbits will take data per day. But it is a 14 orbits and we have got a revenue from all the countries. Okay? All over the world. People are, give me imageries. Please give me your imagery. Your satellite data like that. So what is the second question? Vision is come. I'm coming there. Please, thank you. Next, anything? Senior classes? Please. No problem. No, let it.
Sir, I have a doubt regarding natural satellite, sir. Sir, does moon spin?
Moon?
Spin.
Swings.
Rotates, sir, rotates.
Spins. Yes, it rotates. Why you got a doubt? Okay, that's clear? Okay. Anyhow, Yeah. Next. Please.
Sir, hello sir, my doubt is what more can we do? I mean, how do you develop new satellites? How do you get ideas to create new satellites and how do you develop them, sir?
I'll answer. Okay. Once again I'll answer the last question. Okay. We will develop what happened based on the application. Somebody asks. So I told you that just now I've shown how the vegetation I want. Border I would want to watch. Airport you want to watch. City I want to watch. Correct now? This different areas. Now if somebody comes with you are continuously, I want a daily to be seen by a Ramakrishna Ashram every day. Your school or college, whether it is there or not, that water is there or not. Still we are not gone, but every day, after every 1 hour picture you give. Your water is there in your swimming pool or not, where students are moving or not. To that extent we can do. You are asked, then that is a new application. I asked, a new satellite, how do you get? This is the way we ask. Somebody asks you, if you ask no, you are Swamiji and you ask, I will give you 2 satellites. That's where I get idea to give a big, only Mysore has to cover, only this much resolution has to be there. That is a new idea we will get, we will calculate. So we got 2 scientists here along with me. I will introduce afterwards, end of the speech. Such people will sit and they will give you a new satellite. Okay? Did you got answer? Yes, thank you. Yes. One more question, then I'll go, then I'll come back. And one more session is there. Please, that last person. Wait, I'll ಕೊಡ್ತೀನಿ ಅಪ್ಪ ಇವರೇ ನಾನು ಕೊಡ್ತೀನಿ ಚಾನ್ಸ್ ಕೊಡ್ತೀನಿ ಡೋಂಟ್ ವರಿ ದಟ್ ವಿಲ್ ಗೋ ದಟ್ ಅನದರ್ 3-4 sites are there I'll come back to you everybody will answer if ಸ್ವಾಮೀಜಿ ನಮಸ್ತೆ ಕರೆ ಇವರೇ ಸ್ವಾಮಿಗೆ ನಮಸ್ತೆ ಮಾಡಿ ಅವ್ರಿಗೆ ಎಷ್ಟಂದ್ರೆ 8 ಗಂಟೆ 10 ಗಂಟೆ ತನಕ ಇರ್ತೀನಿ ಡೋಂಟ್ ವರಿ ಪ್ಲೀಸ್ ಟೆಲ್ ಮಿ
Good evening, sir. My question is, so we've all seen this movie Mission Mangal, sir. So Mission Mangal,
Yes.
Mangalyan's
Yes.
movie, sir. So in that they show that they have taken inspiration from a stove, so to save fuel, sir. Is it actually true?
Which one from?
From gas stove, sir. So while cooking, while making puris, sir, sometimes we turn off the gas stove to save the gas, no, sir. So is it actually true that they took inspiration from that and they used it in the satellite to save fuel, sir?
I doubt that. It is not so. It is not fully correct. It is some thing. Because basically what is the physics? See, this is all satellite, all this is what? It is basically physics. Physics converted into the instruments, correct? Am I right? Or you are moving, okay. So that, maybe somebody might have told like that, but it is not the same. Okay? What your answer is not fully correct. It may be partially, okay, really speaking, I have not heard, and here ISRO, we are not taking the from stock. Understood?
So, sir, one last question, sir.
Please ask.
Sir,
Please
why
ask.
do we use gold foil, sir, in satellites?
Gold is a noble material, it will not get rusted, it will not react, and it is a better contact resistance. Understood?
Yes, sir. Yes, sir.
It is a resistance compared to other metals, either copper or a better conductor silver, we will get a rusted, and it is silver oxide or copper oxide will break, and it will get the damage the contact. Gold will not have that.
Okay,
Understand? That's why you use the gold.
So then why not aluminium, sir?
Aluminium is a higher, what you call, it will also go, it will get rusted. Understood?
Yes, sir. Thank you, sir.
Okay, shall I go? So with this, I'll come back to you, all these things. Then one small thing. So with this is satellite applications we have completed. Then I'll go further. For your sake, actually, I've taken some how the orbits are there, how Chandrayaan 1, where I participated. See, this is the how moon will go. Some of the things I want to tell you people. See, this Earth orbits, how it will go. So, see this whenever we launch, so why I want to tell you show is the how we reach moon. So this first Earth orbit, slowly we will raise orbit, raise orbit, raise orbit. So any idea, it is moon is away from how much away from us? Huh? One answer please. Yes, exactly, 384,000. So then we have to go there. We cannot go at a time. We will launch around this and slowly we will go earthbound. Then when goes to the nearby, we will insert, and this 100 kilometers we do. We have to launch it on a November 8th, and then November 8th it has reached moon at earlier 21. So this is called earthbound orbits and goes. Similarly, the Chandrayaan 2 we have gone like this because the two things are there. Lander and moon, both were there. Then slowly we have gone, we have tried to land and we have failed. Have you seen that? We are not able to land. So we'll one more Chandrayaan 3 we will try, we will get it. Failure is a, no problem. In space it is a common, you need not fear for that. Similarly, this Mangalyaan, you asked it. So this is what we have launched on. It is after 220 days, 229, 300 days it has travelled. Around 20 crore kilometers. We have gone and it is launched on 24th September to 2014. So we have got into the Mars and still that it is rotating, it is giving a Mars pictures. So these all things. This is the future mission. Somebody asked, which is the future missions? Sun observations, we use the Aditya mission. So Aditya mission is the future projects. This is the Gaganyaan, is the future missions. Okay? So where we are taking our aim is to take to the future mission that people, there are three astronauts we have to take into the space and bring them safely. Initially we are launching without man, then 2 flights we are launching without people and bringing back around around 400 kilometers above, low Earth orbits 400 kilometers and bringing, after successful launches of 2 things, then we will send the astronauts into the thing. This is what we are our future, or what is our future satellites. This is the program. Then this is the one Aditya, observing the sun, one particular around 1 lakh kilometers, continuously observe how the happens, different kilometers on that. Then this is the references. Okay, sincere thanks to Mahipalananda ji and other people and other Swami, so what is our sir, Bhavan? Huh? Correspondence Swamiji, all these things I am happy to do this. Okay, thank you all. And one more in the, there.
5 minutes question and answer session.
Okay.
6 10.
So I want one. Please give me. Get this mic out. Hello. Some questions. Please select. You, one of you people. Some questions. Many people are asking. One boy promised here. Please ask. This boy, this side. Say 6:10, no, sir? What is that? See, 6:10 we have to close, my dear boys. Huh? 10 minutes is there. One small. Please tell.
Good evening, sir.
Good evening.
Actually, I had a question about turning space into a business, sir. Currently what Blue Origin is doing, trying to make commercial flights, like people can travel in the space, and SpaceX trying to make reusable flights. Basically making space rides okay for everyone. These foreign companies are trying, sir. Is ISRO anywhere near or even planning to do these things, sir?
Yes. We are doing, that's what we are told now. We are able to do, take the people and come back. That was, they are going to the 120 kilometers only. Am I right, Krishmi?
No, sir, but the specially...
they are gone, even foreigners also. And we got, once the human space flight is there, we are going to take and come back. Commercial use or not. So now we don't have commercial plans. Okay. It is a technology. Whether we can take a... Please look at me. See, this is your question only, no?
Yes, sir.
We are not looking for a commercial applications. Never looked for...
Okay, sir.
Ramakrishna Vidyashala. We are all good for this. Understood? Huh?
Yes, sir.
Coming to the... we are always looking for the technology, whether can go and bring back. This is our aim. We can do that. We are able to do that. Next. Your people only select. So, here.
Sir, how do you repair satellites that have been damaged by space debris?
Which one?
How do you repair satellites that have been damaged by space debris?
Okay,
Like
that
important
is
defense
as on now, space debris will not, we are not going to there and it is a costly affair and slowly we are going towards. It is the repairing is more costlier than the, leaving the spacecraft. Am I right? That's coming. If debris it is hit and gets a problem, so in future we have a technology to go and repair it. Right. Next.
Good evening. Many countries launch satellites, sir. For example,
Many countries doesn't have satellites.
no, sir. They launch satellites, sir. If they want to look at the same plane, satellites may collide, no, sir.
No, that's what. Okay, that's there is orbits. See what I shown there. Orbits are there. There is already international telecommunication organization or these some organizations are there. Where to put, how to not to collide. One satellite to other satellite, there is a space. Roughly 1 kilometer, some 1 kilometer space is there. When you go to the orbit, what is the 2 pi r? You are which class? So 2 pi r, what is the circumference of their circle? 2 pi r. When the 2 pi r around 36,000 kilometers is a very big number. There you put the different satellites in a 1 kilometers apart. Understood? Right. So they will not collide. Answer to your question is it will not collide. Okay? Right. Next.
So you said that the polar satellites will go across the polar region, sir.
Yes.
And you said that it will move in strips, sir. Will it cover Area 51?
What the time?
Will it cover Area 51 in America?
Area?
51.
No, I didn't get actually. Area? What is that?
Sir,
Yeah, it covers full globe, including Area 51.
thank you, sir.
What is that? I didn't get actually either question or... please. That is grids. See, last slide. Last slide of that was the area is there. Grids they wanted. Grids. Okay, right, next.
Good evening, sir. Which is the smallest satellite launched by India?
Smallest satellite launched by India. 10 kg satellite we have launched recently. INS. Indian nano satellite 10 kg. Earlier, otherwise we are 150, 120 kgs, 100 kgs, 500 kgs, 600 kgs, 1000, 1200 kgs, whereas communication satellites is 2000, 3000, 6000 kgs also there. It's the smallest is 15 kg satellite we have launched. Okay, right.
Sir, does NASA produce better satellites or ISRO produce better satellites, sir?
Does NASA
Produce better satellites or does ISRO produce better satellites?
If you are asking me that question, it is equally good. We are second to none. Okay? It is second to none means ಅವರೆಷ್ಟು ಮಾಡ್ತೀರೋ ನಾವು ಅಷ್ಟೇ ಮಾಡ್ತೀವಿ. We do that. Some quality, some of the things we are good.
Thank you, sir.
Currently we have a resolution of around 0.3 meter, which is on par with the world-class satellites. Okay, we have a collaboration with NASA also for the next upcoming mission, where they are giving the payload and we are making the satellite, and data will be shared.
They are giving to us. So, NASA is collaborating with us. Many American payloads are given on Chandrayaan-1 and Mars mission also. Right. Okay, now one small thing I'll tell. Okay, continue.
Sir, what are the educational qualifications required to join ISRO?
Okay, this exactly I kept money. Okay, it is please read your physics, mathematics, chemistry that I am coming that satellite. After this, see, you read well about your mathematics, physics, chemistry and science neatly. Your Ramakrishna Ashram, get up. So he is a scientist from your Ramakrishna Ashram. He is one of the finest sensors in the US. Okay. He has studied physics. He knows mathematics. I understand. Okay, and then I'll actually the two slides I skipped, I'll come back to you. Right. Okay, right. Now you go to my old presentation. Can you go? Old presentation. That's right. Okay. Sir, are you happy? Application. That I'll do. I'll close. Yeah. Second one. No. All the entire. The first 3 slides. ISRO organization. Actually, there are tiles are there. Go. Right. Go further. First, second, third. Next. Yes. You keep there. Back. Yes. There. Back. No, previous. Hello, how to become a scientist you are told. My dear children, that's what they came here to tell. Swamiji has asked how to get into ISRO. ISRO, you read well the physics, chemistry, mathematics first. In the 12th class also you read. And engineering, you get any branch. That's what I want to tell you. Don't work hard, sincere and do that. I am telling you, the department ISRO works like this. Prime Minister is our minister. Space Commission is the Department of Space. We work on that. ISRO is here, and here VSSC. Rockets will make. Mechanical engineers, chemical engineers. It is a rocket fuel. Liquid Propulsion System Center. Here the chemical engineers, mechanical engineers. Material scientists will be there. Here the launch pad. It is the Sri Harikota. Mechanical engineers, safety engineers, and the chemical engineers. Electronic engineers minor here. Whereas here the mechanical engineers and electronic engineers equal. Here the mechanical engineering is more. Here, this is the URSC where I am coming from. Where we make a satellite. UR Space and Satellite Center. Satellites will make. And this satellite center will make electronic engineers, mechanical engineers and the small now the computer engineers also is coming here. Now develop. And next SAC, physics, optics, science, MSc, doctorate in MSc, that space application. How to use the space applications in that. NRSC, just now I shown all the figures, that is the computer science, natural remote sensing satellites, where the data image processing will be done, taking the satellite data and it is released, okay? Right. See, like that IPRC chemical, this is the standard, there are controls, electronics and all. All these things, electronics, mechanical, physics, chemistry, if you are good at and you are doing that, you are going to get into the ISRO. Understood? Clear? So, and it is across the day, our ISRO is there all over the India. We are all together, Indians are all together. It is everywhere it is there. See, here rockets will make, here launch cycle, satellites, here the space applications, it is the control centers, it is the observation centers, this is all the earth resources what we do. So, we are all one, we will take, understand. Got it? Mechanical, electronics, good, you study well fundamentals. That where you get into the ISRO. Clear? Right. Next. So next, one last. Only 1 minute. Okay, I was very much impressed, Vivekananda. See, when I studied like you in the 12th class and as well as my diploma, a special diploma course, but I was doing, I was having a called Thus Spake Vivekananda. This Vivekananda is inspired every time I read this and I'll tell. For your glimpse, it is like a bullet. This is what I want a nation actually has called. Strength, strength, strength. What Upanishad speaks to every page. We want strength and every time strength. All the power is within you and everything you can do and anything you can do. Believe in that. Believe that you are not weak. Okay, do not believe that you are off crazy lunatics. Most of Philippines nowadays, you can do anything and everything without even guidance of anyone. All power is there. Stand up and express divinity. And all these qualities will come. No need looking behind. Forward, we want infinite energy, infinite zeal, infinite courage, infinite patience. Then only great things will achieve. It is what the mantra is given by Vivekananda. When I was young like you, 12th class to 13th, 14th class, I read this. Even today, it inspires me. This is the strength. We are all there. Bye.
I thank Sir for his wonderful address, and I'm sure everybody enjoyed the address by Sir. And Sir explained to us about the various technicalities of ISRO and the satellites, and I'm sure this is a beautiful address. Now I would like Swamiji to hand over Sir a small memento as a token of our appreciation. Now I would like BSV Sir to hand over a small memento as a token of our appreciation to the scientists and Mrs. Mamta. I request everybody to rise. We'll end the program with Purnamadav.
Om Purnamadav Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnamevavashishyate Om Shanti 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 Hari Om Tat Sat Sri Ramakrishna Arpanamastu.
PUC students are requested to leave first. Others